All right, this problem starts out by telling us that we have a 21 gram sample of xenon. Grams of xenon isn't anything that can go into one of our laws, so we're going to change this to moles. So we look on the periodic table and we see that 131.29 grams of xenon is its molar mass, so that's equal to 1 mole of xenon. And what that tells us is that 0.15995 moles of xenon is our sample size. So we're going to say N equals 0.15995 moles. It tells us we have a volume of 958 milliliters at a pressure of 3.67 atmospheres, and it wants us to find the temperature. Now, it wants us to get the temperature in Celsius, but of course we're going to have to solve for it in Kelvin first. We don't have any duplicates, so we're going to be using PV equals nRT, the ideal gas law. We have to determine what our R is going to be, and since we have pressure units of atmospheres, R is going to be 0.0821. So let's plug things in. P is 3.67, V is in milliliters, and we've got to change that to liters for the ideal gas law. So 0.958 liters. N is that number we calculated, 0.15995. R is 0.0821. And T is what we're trying to solve for. All right, we do the math and we get T to equal 275.4 Kelvin. But since our answer wants Celsius, we subtract 273 and we get 2.4 degrees Celsius. All right, this one says that we want to inflate a baggie with the volume of 958 milliliters by filling it with xenon gas at a pressure of 0.651 atmospheres and a temperature of 304 Kelvin. It asks us how many grams of xenon we need. Now we can't put grams into the formula, but we can solve for moles and then convert that to grams. So we're going to try to solve for moles of xenon. We don't have any duplicates, so we're going to use PV equals nRT. We have to look at our units. We must change volume to liters. Atmospheres is good, and it's going to make our R 0.0821. Kelvin is the right temperature. Moles is correct for N. And when we solve for N, we get 0.02499 moles. So we're going to convert 0.02499 moles of xenon to grams. And we get 3.28 grams of xenon as our answer. Okay, this problem tells us that we have a sample of nitrogen gas collected at STP. STP stands for standard temperature and pressure, and the standard temperature is 0 degrees Celsius, which is equal to 273 Kelvin, and the standard pressure is 1 atmosphere. We have a volume of 30.9 liters. How many moles does that contain? So we don't have any duplicates, so we're going to use PV equals nRT, and since our pressure is in atmospheres, our R, our gas constant, is going to be 0.0821. We plug numbers in and we solve for N. Now this problem does not ask us to convert to grams, but I do want to point out with nitrogen gas or anything else that's in Hofbrinkel, if you were to convert it to grams, you would want to remember that each of these have a subscript of 2. So N2 would be the molar mass that you were looking for. But in this case, this is our answer.